Let us start today's lecture. In today's lecture, we will discuss about a topic that is homeomorphism. We all know that the definition of homeomorphism, it is a bijective continuous map from one metric space to another, and its inverse is also continuous. Then we can say that mapping is homeomorphism. Okay, so my question is every homeomorphism, question goes like this, is every homeomorphism from two sphere to itself going to have a fixed point? This is my question pertaining to homeomorphism. And again, if we are going to take a homeomorphism from a sphere means a set, a kind of set from R3 to itself, does it going to have a fixed point? My question is that. Fixed point means if f of x is equal to x. This is the definition of fixed point. And what is the definition of S2? S2 means sphere, two sphere. That is always going to be the subset of R3, and that means space. And we are going to define it like this: set of all x belongs to R3 such that norm of x is equal to R. Okay, that is just the generalization of circle, and we call circle S1. So this is the definition of two sphere. And my question is every homeomorphism, suppose that f is homeomorphism from S2 to S2, does it always going to have a fixed point? If this is a homeomorphism, is it going to have a fixed point? Fixed point means this. We know in R, if we are going to take, we know in usual metric space R, if f is a continuous map from 0 1 to 0 1, then it always going to have a fixed point. We know that. What about this? Is this homeomorphism going to attain the fixed point? Is every homeomorphism going to attain the fixed point from S2 to S2? So let's take an example. For example, let me take f from S2 to S2 and define it like this: f of x is equal to minus x. Since homeomorphism is always a continuous function and it must be bijective, inverse image must be continuous, is this a homeomorphism from S2 to S2? Yes, obviously this is a homeomorphism. And this x is not the real x. It is going to be a vector from R3, which is going to satisfy this. So is this function going to have a fixed point? Let's assume that this has a fixed point. Fixed point means f of x equal to x. For fixed points, f of x must be x. That means f of any vector must be the same vector. So, but f of x equal to minus x, which implies x is equal to minus x. When this is possible? In R3, this is possible if and only if x is 0 vector. Okay, but is this going to be contained in this S2? No, because this contains all the points whose norm is going to be R. That means set of all points whose distance from origin must be R. But R is some non-zero real number definitely, but this is not going to satisfy this. If radius is non-zero, then this point is not going to lie on this S2. Okay, so that means there exists a homeomorphism from a sphere to itself, which is homeomorphism, but that does not contain any fixed point. So that means this kind of homeomorphism need not necessarily contain a fixed point. Okay, my next question goes like this: is 0, 1 homeomorphic to open interval 0, 1? Is this homeomorphic to this? The answer is no, they are not. They are not homeomorphic. What is the reason? The reason is, if we are going to take any point from this and if we will remove that point, it will become sometimes disconnected, sometimes connected. Because if we are going to remove 0 from this set, if we will remove 0 from this first interval, it will become 0, 1, and this is still connected. This is connected. However, this property is not going to associate with this, because if we are going to remove any point from this, it will become disconnected. There does not exist a single point if we will remove that from this set, and it will still remain connected. That means we have removed one point from this, that is 0, and still it is connected. But that property is not going to lie with this set. That means we can say that these two sets are not connected. Okay, I think now it is clear that this is not going to be homeomorphic to this. I think this is sufficient for today.